Okay, this is my Sprint 3 video report. First was OBB collisions, so this was a diagram of what I have. This is all the old stuff, so our system. And then collidables have collision volumes. That's what this is. But now collision volumes can be several different things, so B-sphere over here, and then OBB and ABB, and then bounding docks base as their parent. Still, the visitor pattern is three-way, so intersect, accept, and intersect visit are on the three of these. Bounding box base just has all of the things that are common to boxes, so all of these things to keep track of. Yeah, and then just in terms of visualizer, not much to show here, but the visualizer, when you ask to visualize any of these things, there are B-sphere commands, B-sphere commands and box commands that are recycled, so you can use the box commands to draw either OBBs or ABBs, just based on their min and max and, scaling appropriately and everything. So, sorry, I need to go over here actually. And what is interesting about this? Math is interesting. Here are all the headers for all my math stuff, so I added in a ton of stuff to help with the OBB math. Here's the specific OBB, or these are just two boxes intersecting, so this can be ABB, OBB, or OBB, OBB. I'm not being very space efficient. I'm putting all the different axes in a vector, an array of 15 vectors. I don't know, it makes most sense in my head, but maybe that's space inefficient. Making sure those vectors are non-zero, and then doing the overlap along the axis, and all the math is tucked away in here. What else? It was a while since I did all this, so min and max are calculated once for the OBB at the beginning. For computing the data, you call the base class compute data, which updates the center and the scaling factor, so both the ABB and OBB use this. For ABB, the world matrix is set to the identity matrix once at the beginning, since the min and max are already in world space. Yeah, I should run it. Sorry, I'm tired. In my test scene, I have one frigate, and the frigate has a OBB collision volume, as you can see right here. I said it is OBB, and then I have three cottages, and they have OBB, B-sphere, and ABB. So if I switch to GAM and move around to a helpful spot, I do have the problem, I mean, I guess it's not a problem, but where, it won't turn blue. There was that whole Discord it won't turn red. There was that whole Discord message about that, but it is actually colliding. You can see in the bottom, and I promise if only one cottage is on here, the frigate would turn red every time it collided, but we talked about that. So this is with OBB. As you can see, the cottage is rotated a bit, but it's so is the box. So that's working fine. Even if I scale up and down, it's working fine with OBB. And then if I go over here, this is an AABB. As you can see, the cottage is rotated, and the box is still axis aligned. And this happened to be the last one drawn, so the guy does turn red. But yeah, that's working fine. And then last is B-sphere, which is also working fine. I don't have any of the lines or markers for the debugging stuff, but interesting. Okay. Anyways, and memory, whatever. Yeah, that's all I have for that. In terms of personal project, ooh, I meant to have my document pulled up. Give me a second. Not the beginning part isn't much different. I have an actual UML diagram because I actually put all this stuff in there, so it has changed a little bit. I'm not sure this is perfect, but basically the different you have the pages like I talked about, and then you put UI elements in the pages. UI elements can be different things, so text blocks, buttons, soon to be progress bars, etc. And so I have these text blocks and buttons inheriting from different base classes, so it can just be drawable, hoverable, or clickable. So like a button is all three of those things, but a text block isn't clickable, so it's just drawable and hoverable. I don't know if that's like the most logical way to do it, but whatever. Not whatever in that I won't fix it, but that's just what I'm working with now. And then in terms of like, this stuff is all pretty much the same, but in terms of like this visible, non-visible, active, non-active stuff, I thought about the page can just, like the user can just add and remove things from the page. So basically the page has 3 lists of hoverables, drawables, and it's not here yet, but clickables. And so you can like add a button to the clickable list, and then you can take it out if you don't want it to be active anymore. But a button could be in the drawable list and not in the clickable list, so that it's still drawn on the screen but is like deactivated or whatever. So yeah, if that makes any sense. And then let me just show that. So that's this. And there is this is my whole diagram in more detail. And basically I added all of these classes for UI system. The base class is drawable, hoverable, and clickable. Clickable isn't doing anything right now, but basically a drawable has a sprite, rectangle, color. Hoverable, you can check if it's overlapping, and it has on hover, which is virtual, so the user implements that. I don't know in how much detail to go, but the scene, basically each scene has a UI manager, and a UI manager has a current page. So in the scene draw, after it draws it calls draw on everything, then it calls UI manager process elements, which is this, which will just go to the current page process elements, and then in page process elements, it loops through the hover, like right now I don't have clickables, but I have hoverables and drawables. So it'll loop through all the hoverables, see if anything overlaps, and if it does overlap, do call on hover on all of them, and then I loop through all the drawables and I draw all of them. Okay, yeah, if I go down to the actual, like, how the user would use this, in this scene, I am creating a test page, and then I'm setting the current test page to that page. So set current page, it goes through the scene and then goes to the UI manager via the scene. So here's a test page. This is what a text page looks like. It basically has these 2 text blocks. So these text blocks are it's just one thing, but 2 instances of one thing. So creating the first text block, and then this text block is going to be drawable and hoverable. So you add it to both of those. You position it with a rectangle. So this one's going to be in the bottom left, 100 by 100, and then I'm setting the color to red. I'm doing another instance of that text block, making this one drawable and hoverable, putting it a little higher up, and then setting the color to olive green. And then in the test text block, I have the on hover. So when you hover on either one of these, they're going to turn coral because I set the color here. I had to do some shenanigans to get color working, but it's working fine. So excuse me, man. Okay, so here's my mouse, and you can see it's printing where the mouse is. Basically the page is keeping track of where the mouse is, because you can just get the mouse instance from Azul and get the position. And then I have an intersect function in the math tools where if the mouse intersects with this. So that didn't seem quite right, did it? Maybe it's not perfect. Let me try again. Anyway, when you hover over... Oh, yeah. That's not perfect. I feel like it was working earlier. Maybe it's... Anyway, that's irritating. But the idea is that when it hovers over... Okay, my math just might be wrong or something. But that seemed right. Okay, anyway, it depends a little bit. But the idea is when you hover over, I have to tweak that to get it working right. But you see these things actually have an effect based on what the user wrote. Yeah, so preliminary, not super exciting. A lot of classes for not a lot of result. But I have some kind of structure there, and I think it is going to be expandable to some degree. So, yeah. And then my game, I have not done much. I'm uninspired at the moment, but it will happen eventually. So the document, I haven't changed at all. But I will at some point. So yeah, I think I need to stop talking. Yeah, that's it.